Hello, this is Brian Hopkins. I'm going to talk about soil testing today. Look at a few slides. I'm going to cover this fairly briefly. I've actually got a much longer version of this presentation for more depth, but this is just an emphasis on how we do soil testing with turf grass, which is a little more simple and different than if I was sampling for a farm or for some other more complicated situations like vegetable gardens or something. But when we're focused on turf, it's kind of simple, and let's dive right in. So soil testing is important. It's how we should base our fertility program, and not our like fertility of having babies. That's not what we're talking about. We're talking about soil fertility, which means the nutrition of what the plants need. We also use it to evaluate salinity and sodicity, as well as to potentially identify toxicities that might happen. Generally speaking, every 3 to 4, even 5 years is ample to take a sample, unless there's some specific problem that we're looking at. That's usually enough frequency. We want to have separate evaluations for each unique soil type and management area. I've got a little video that you can look at associated with this, showing me taking a sample. I'll explain that a little bit more depth. One of the things we look at is sample type. Different types of plant material grow in soils of different types. So if I'm growing turf grass on a sand-based sports field or a golf green tee box, that's going to be pretty different than almost every other situation where we have more of a loam type of soils. So we definitely see some differences out there. And if you have some differences in soil type, especially the CEC, and across the landscape, we would want to sample those separately, as well as anywhere we've managed it differently, or other soil properties potentially as well. But this is one of the obvious differences. So, for example, on a golf course, I've got a sand-based green versus the native soil out in the fairway. Those are managed differently, fertilized differently. They have different materials in terms of the soil. So we would want to sample them separately. That's just one example. Okay, the CC is an important property in terms of one of the things we test for. We don't usually analyze for CC directly. Rather, we tend to get an estimate of this, but this evaluates the soil's ability to hold the nutrients. Soils are negatively charged, and positively charged nutrients can be held onto the cation exchange complex. The greater the surface area of the soil, the greater the CEC. So clays and organic matters tend to have large CEC. Sands and silts have very little CEC. Well, in other words, little nutrient holding capacity. It's also related to water holding capacity, similar kind of a thing. So water nutrient holding capacities tends to be much higher in sands, in clays and high organic matter soils than it does in sands or silt soils. pH is one of the things that we're interested in. Again, we'll talk about this more in other videos, but we're interested in if the soil is acidic, if it's neutral, if it's basic. It affects nutrient availability, as shown here in this little diagram, showing that essentially, in principle, the nutrients tend to be more available at neutral pHs. As we get on either side of that into acidic or alkaline, or what we call basic areas, we have less nutrient availability. So that's an important thing we want to test for. We look at these acidic soils. Typically, those are things like in the eastern United States where we get a lot of rainfall, or even up, high mountains, or in Seattle, in Portland, places where it rains a lot tend to have acid soils. The reason we're interested in that not only is nutrient things listed here, but also toxicities. Aluminum, most common, but also manganese, and there's some other potentials as well. Usually it's one of those two. And if we get a low pH with the soil test, we raise it by adding limestone or some kind of a liming agent. Alkaline soils, we also call that basic, depending on, the chemists tend to talk about, bases, basic. In soils, we usually say alkaline instead, but it's the synonymous term. We also see some nutrient deficiency problems in these high pH soils. Often these soils have free excess lime. We call them calcareous, which presents further problems for nutrient availability. It is possible to lower the pH, but generally we say don't do that. It's too expensive. It's not worth it. And instead, we just want to address nutrient deficiencies according to soil test. We again, one of the main purposes of soil testing is to look at the availability of nutrients. Some of these tests are really good, like potassium and phosphorus. Others are not so good, like nitrate. It's not a meaningful test. It's accurate, but the problem with that is that it changes so rapidly in terms of plants taking it up. If I get a rain, it can leach it out. It's such a transient number that we oftentimes kind of steer away from it. Whereas phosphorus or potassium, for example, they tend to kind of track. If it's high, this month, it's going to be high next month. Whereas nitrate, that's not necessarily true. Now, in contrast, the sulfur and the iron tests, they're just not well correlated to nutrition. So I don't put a lot of faith in them, and so they're just not as good. There are different soil extractant tests will give different results. We need to understand that. I'm not going to go into much detail there, other than it's important to work closely with the lab to make sure that whatever number they're giving us, let's say, for example, phosphorus. Let's say I am in the East and I have a Malic 3 extraction on my soil. Well, I would want to use a chart to interpret that based on Malic 3 research. And if I'm in Colorado and they use a different extraction, like the bicarbonate method, I would want to make sure that the interpretation is based on that extracted. The analogy would be temperature. If you tell me it's 32 degrees, I don't know what that means unless you tell me what scale it is. Because 32 degrees Fahrenheit is pretty cold, freezing. 32 degrees Celsius, pretty warm. So similarly with these tests, a Malic 3 part 32 part per million is different than a bicarb part per million. So that's just a little nuance. It's important to again, to make sure you know what test is being run and make sure that when it's being interpreted, that you're using the right tables for interpretation. Nitrogen, potassium, and sulfur are most likely to be deficient. So that's important from a soil testing perspective. We typically wouldn't want to apply any more than 1 pound per 1,000 square feet of any of these soluble salt-based fertilizers to avoid salt burn. Now, sometimes we will apply slow release materials higher than that rate, but we want to be careful. These are nutrients, but they're salts. And salts are important. We need them. You and I need them. Plants need them. But too much is bad. It can kill. These three are really very soluble, and they're more likely to burn than, say, phosphorus. Plant tissue analysis is another thing. I'm just going to mention it briefly. It doesn't replace soil testing. I often use it for troubleshooting. I compare tissues of identical management zones and species, and yet have different visual symptoms. So, for example, somebody says, hey, I got these, this turf grass over here. It's yellow. I would go out there, look at it, potentially pull both soil and tissue samples in the yellow and compare them to green areas as long as the soils are similar. But oftentimes that can help me pick out what's the problem. Is it a nutritional issue? Is it a water issue? By doing that comparative sampling and analysis. It's also important to keep records, keep and plot these analysis over time. I can kind of see trends, what's going on in the soil, and I can be a better manager if I use those good records. One of the things we're interested in, I mentioned earlier, is sodium and other salts. We call this salinity and sodicity. Salinity is when a salts in general are affecting soil. Sodicity is when sodium specifically is causing problems in soils. We see these saline soils. Here's kind of the properties. A normal soil has a pH of less than 8.5. EC, which is electrical conductivity. We use that as a measure for salts because salts in water dissolved into the soil water conduct electricity. So the more salts, the higher the conductivity. So normal soils, less than 4. And then we have this ESP or SAR, which is the exchangeable sodium percentage or the sodium absorption ratio. Those are two different tests. Sometimes we run one, sometimes we run the other, sometimes we run both. But typically those are less than 15% sodium exchangeable or less than 12 of the SAR. When I get a saline soil, that's when the EC gets high, the other numbers stay normal. A sodic soil is when these numbers creep up above 15% or 12 SAR. And then a saline sodic soil is I've got both issues, high salts and high sodium salt. So the sodic soils, again, the technical definition of that is on the previous slide. But when I'm doing soil analysis, I don't want to wait till I get into trouble. I'm monitoring it. If it starts creeping up, then I need to act now. I need to be proactive. And so I usually say 5% is being kind of my red flag. If my soil test is above that, then I start saying, hey, we got a sodic soil developing here, and let's fix that. It can destroy the soil structure is the problem. And we want to get that corrected by adding some type of soluble calcium source, gypsum being the most common thing that we would apply to a sodic soil. The idea is that we want to increase the amount of calcium relative to sodium in order to prevent the problem or in order to correct. Salinity, again, is salts, desiccates the plants. You get so many salts that the salts have an affinity for the water, and it prevents the plants from taking up the water. And so you can have a lot of water, but plants are dying of thirst. Again, EC of 4 is kind of the magic number. Plants growing on these high EC soils are more susceptible to burn from high salt water or fertilizer. So we need to realize that. And we have to be a little bit more careful when we have ECs that are creeping up on us. Now, that way we fix these is we make sure we can drain these soils, and then we leach with good quality water. We try to push the salts through the soil in order to create a more hospitable environment for roots and plants to grow. Again, correcting these major adjustments are best made at establishment. If we are installing a new sod, we would want to have the soil tested. And if we have these problems, potentially reject that as the topsoil. If it's already in place, we need to try to fix it before we start putting the sod down or planting seed. If my turf is already established, I'm kind of limited on how much I can apply of these materials like gypsum. I would never want to put on more than 50 pounds per 1,000 square feet of gypsum in the case of the sodic soil, or lime, going back to the acid soils. In both of those cases, we're usually applying large quantities, much more than we apply as fertilizer. And we want to be careful not to just, overwhelm the grass by covering with the whole pile of this stuff. So we want to be careful to do that. We usually do it during cooler weather. So, okay, that's a little presentation that we have there. Let's just look at a couple of other things. I wanted to show some examples of some soil tests. Let's see. Oh, first of all, actually, so I went through that really fast. I have a longer video that kind of explains things ad nauseum, but this document is how to interpret a soil test. So I'm not going through everything right now, but this document is provided. You're welcome to it. It's me writing this up and kind of how to interpret a soil test. So if I get a soil test like this one here, I would look at these numbers and say, well, okay, what does it mean? I have a pH of 7. What does that mean? Well, this lab is providing for some level of interpretation. They're calling it medium. And every lab is a little different in terms of how they present their soil tests and what their criteria are. That's something to be aware of. Here's another lab, Servitec Laboratories lab I used to work for. They do great work. One of many labs that do good work. But so here they're also showing like soil pH. This is 7.8, and they're showing that, hey, this is up here in the alkaline range. A little bit different way of presenting the data. They are presenting several other things here. You'll notice that, like here's potassium 507, and they're saying it's very high. In fact, nothing on this soil test is in the low range, which, and I see this pretty commonly in the urban environment, not so much with farms that tend to be a little more frugal with their fertilizers and a little more judicious. And in the urban environment, we are a little bit guilty of over fertilizing. And I often see these kinds of reports being just really high and beyond what you even need. Again, we want to take a good soil sample. It all starts there. I'm not going to go through all that. There's another little video you can watch again about how to take a soil sample. Tons of guides around. Here's just one example. If you Google how to take a soil sample, you can find that information. But it does start there. It starts with taking a good soil sample. You need to send it to a good lab that participates in proficiency testing, like the North American Proficiency Testing Program. I highly recommend that. Labs need to participate in something like that. It's the burden of proof is kind of on them to say, yes, we are good at doing what we do. Because if you take a great sample and get garbage analysis, your soil test means nothing. And that's definitely a possibility. And then how do we interpret it? Again, we kind of come back to this. Whoops, where was I? Here we go. How do we interpret it? It really is a three-phase process: is taking the right sample, getting a good analysis, and then doing a proper soil interpretation. So that's what we got for you today. Hopefully that was helpful. Soil testing is really important. I always like to say, don't guess, soil test.